You are given an integer n and a 2D integer array queries. There are n cities numbered from 0 to n minus 1. Initially, there is a unidirectional road from city I to city I plus 1 for all 0 less than or equal to I less than n minus 1. Queries of I equals ui v of I represents the addition of a new unidirectional road from city ui to city vi. After each query, you need to find the length of the shortest path from city 0 to city n minus 1. Return an array answer where each I in the range 0 to query's length minus 1 answers I is the length of the shortest path from city 0 to city n minus 1 after processing the first I plus 1 queries. So what this means is that we're given a number of cities and a number of queries, and this just means that we're building new roads. Our output is just going to be the distance from city 0 to our last city, in this case, city 4. After building additional roads, we want to know the new shortest path from city 0 to city 4. So initially, our path from city 0 to city 4 is just going to be a length of 4. It's not shown here, but if you just count backwards from 4 to 3, 2 to 1 to 0, this should be just a length of 4. But when we add our new additional road, this 2 to 4, this 2 to 4 right here, this length will change from 4 to 3. And adding additional roads will just keep updating our shortest path. Our output is just going to be this array of shortest paths on each addition of a new road. So the way that we're going to approach this problem is through dynamic programming. And let's just set up a DP array here. And the way that dynamic programming works is we just take smaller answers and we build up to larger answers. If you're not familiar with dynamic programming, just go check out my video on climbing stairs and it'll give you a more in-depth view on this topic. But the grand question that we want to ask is, how do we get from 4 to 0? How many steps is that going to take? And to do that, we ask smaller questions. We say, how do we get from 4 to all of these other nodes? From 4 to itself, it's simple. It's just going to be 0. From 4 to 3, it's just going to be 1, 2, 3, and 4. And now when we add this road from 2 to 4, we need to now update our solution. So we're going to update our dynamic programming array, and we're going to say from 4 to 4, it's still going to be 0. From 3 to 4, it's just going to be 1. And now from 2 to 4, it's also going to be 1. This is going to become 2, and this is going to become 3. And then once we finish updating our DP array, we're just going to take DP of 0, and then we're just going to add it to an answer list. So our answer right now is going to be 3. So how did I know how to update these nodes? Well, it's pretty simple. We just look at the next node that it points to, and in our DP array, we're just going to take that node and just add 1 to it. So because we point from 2 to 4 now, we're just going to look at DP of 4, so we get this 0. And for DP of 2, we're just going to add whatever value is here plus 1. So from this 4 to 2, we're just going to take this 0 and add 1 to it to get 1. And the same goes for the rest of these. 2 to 1, just add 1. From 1 to 0, we just add 1. So let's continue on now. Let's add this green road from 0 to 2, and let's update our array. But before we start, let's actually recognize something. We actually don't need to go from 4 all the way to 0. We only have to take our destination, this 0 to 2, so this 2 right here, and we only have to update from 2 backwards because we know that the rest of this array is just going to be the same anyway. So I'm actually not going to even fill in this portion over here. We're just going to go from 2 to 0. And we're going to say, from 2 to 0, we know it's still just going to be 1. From 1 to 2 is going to be 2, because we have to add 1 to this 1 to get 2. And from 0 now to 2, we know that we have this new road. So we have to take the minimum between either this one plus 1 or this one plus 1. So it's either going to be this one plus 1 or this one plus 1. Our new 0 is just going to be 2. And we're going to add our new DP of 0 to our answer. So 2. So now let's add our last road, this 0 to 4. And because we're adding our destination node of 4, we're going to need to update the rest of our array. So let's put a new array here. I'm going to say from 4 to 4 is going to be 0. 1, here is going to be 1. Here is going to be 2. And now here is going to be 1 because we look from our 4 and we're going to add 1 to it. Now we're just going to take our DP of 0 and add it to our answer array. So 1 here. And this is how we got our first answer. So I want to make clear that it's pretty obvious that this 0, 4 is going to be our shortest path from our start city to our end city, but we're actually comparing all arrows that are leaving this start city. So we're doing this 0, 4, this green one right here, and even this purple arrow that's leading to the first city. We want to make sure that we're taking the minimum of each one of these and then adding it to our start city. And this goes for all cities that have multiple arrows leaving it. So we want to compare this one, and this one. And the minimum of these is going to be our +1 for the city. So let's start coding up our solution. We were using a graph and we were using a DP array, and that's going to look like this. This syntax just means that we're going to be counting down from our first node to our last node. And if you want to see that, let's just print that out real quick. Print DP run, and it should look like this. So we are going to be using a graph, but we're also going to be setting it up a little bit differently. In our picture example, we're all pointing towards the last node, but this makes it difficult to update our DP array. If we in fact reverse all of these arrows, so we're able to point back to previous nodes, all nodes leading back to our first node, it'll actually be easier to update. We could call this graph, but I'm just going to change the name of it to something more appropriately named. I'm going to call it reverse graph. And to initialize it, it'll look like this. And I just want to show you what it looks like as well. So we can say print reverse graph, run it. And you can see that we're just setting up a adjacency list to represent our graph. So 4 will point to 3, 3 will point to 2, 2 will point to 1. What we should expect for the initialization of our graph, except all reversed. So let's close this up. And now that we have our data structures set up, let's start moving into our algorithm. So we want to get each road in our queries. Let's call this source and destination. So source, destination. This would be like a source, this would be a destination. Pretty much the source is where we're pointing from, and the destination is where we're pointing to. And every time we get a new road, we want to update our graph. And because we're using a reverse graph, we're just going to take our destination and append the source. So again, this is just a adjacency list, and this will point to all of its neighbors. So now that we updated our graph, we want to now update our DP array. So we're going to iterate backwards, like in our picture example, starting from our destination node, and we take all neighbors within a node that we visit, and we take the minimum of each one of those nodes. After updating all the nodes, we're just going to take the DP of 0, so whatever our first city is, let's just add an answer right here. So this actually updates. And then after everything's done, we're just going to return the answer. So let's see if this runs. Let's see if this submits. And there we go. Like, subscribe. A link to the code will be in the description. Join our Discord for some extra help, problem suggestions, and announcements. And I'll see you in the next one.